Welcome to this explainer. Today, we're doing a complete teardown and rebuild of your Java toolkit. For way too long, Java has carried this heavy baggage of being slow, kind of clunky, and just tied down by endless boilerplate. But today, we're leaving those outdated stereotypes completely behind and stepping right into the cutting-edge reality of the modern Java 25 ecosystem. Let's just address the elephant in the room right off the bat, okay? This is something that's haunted enterprise developers for years. We've all heard the jokes, we've all felt the pain. The big question, is Java still too verbose, aggressively memory-hungry, and painfully slow to start? Well, spoiler alert, absolutely not anymore. The platform has undergone a massive evolution, and the tools that we have today is practically unrecognizable from the Java of 10 years ago. So, to shatter those old stereotypes once and for all, here is our roadmap for today. Number 1, the Java 25 revolution. Number 2, concurrency and instant startup. Number 3, mastering Z garbage collector. And finally, number 4, staying current with Java podcasts.
All right, kicking things off with Section 1, the Java 25 revolution. This is, without a doubt, the biggest release this ecosystem has seen in years.
You know what's amazing right out of the gate? The end of all that unnecessary ceremony. Think about the old way of doing things. You had to write these verbose class declarations and string arrays, literally just to get to a single line of logic. It was a huge barrier for beginners and honestly just annoying for veterans. Well, modern Java 25 gives you an implicit void main and a global io.println. It strips away the clutter, making the language incredibly inviting. It really makes Java feel just as agile as Python or Node.
And it gets better. Remember that 30-line block of shame you used to maintain at the top of your files just to import standard utilities, collections, and I/O streams? Now, a simple module import of java.base gives you lists, maps, and streams with zero extra typing. It's like a magic wand. It elegantly resolves naming collisions behind the scenes, leaving your code super clean and focused strictly on the actual business logic.
This release is also just absolutely packed with massive quality of life changes. For starters, it finally allows logic checks before initializing a parent class. That means no more messy static helper workarounds when you're extending classes. It also treats primitives as first-class citizens in pattern matching. Oh, and it even includes a built-in PEM decoder for security certificates, plus a unified API for cryptography keys. Basically, you can finally drop those bloated third-party security libraries, which lowers your dependencies and patches up potential vulnerabilities. Now, digging under the hood a bit, we have Project Lilliput. This is fundamentally changing how objects are stored in memory. Historically, every single object in Java carried a hidden 128-bit metadata tax. Project Lilliput slashes that header right down to just 64 bits. When you remember that enterprise apps generate millions of objects a second, cutting that metadata overhead in half is literally a game changer. So, what does this all mean for you? The crucial point here is that without changing a single line of your code, simply upgrading your runtime means your application's RAM usage could drop by 10 to 20%. For high-scale microservices running across dozens of containers, that translates directly to drastically lower cloud bills. Moving right along to Section 2. Concurrency and instant startup. Let's see how we can execute this modern code with zero warm-ups. Okay, so Java 25 finally dethrones the memory leak king by replacing the old heavy thread local with scoped values. These new scoped values act almost like a locked vault. They're completely immutable, they have a strictly defined lifespan bound to a specific task, and they ban lazy null fallbacks. This forces you to handle missing data properly at compile time, empowering you to write robust, crash-proof concurrent code that automatically cleans up after itself. And to fix Java's legacy reputation for slow startups, we now have two incredible tools. Project Leyden lets you run a training mode on your application to create an ahead-of-time cache, which lets you skip the painful just-in-time compilation warm-up entirely. Meanwhile, GrailVM takes it a step further by compiling your app directly into a standalone native machine code executable, bypassing the traditional JVM execution altogether. Honestly, compiling your app into a native binary is shockingly streamlined today. You just add the native image plugin to Maven or Gradle, run the native compile command, and execute the resulting binary. That's it. Your app will start in milliseconds and deliver peak performance from the very first request. Imagine never waiting for a JVM to warm up in production again. Your instances can just scale out instantly to meet traffic spikes.
Awesome. Let's jump into section 3, mastering Z garbage collector, so we can optimize how we manage memory. Now that our app is running blazing fast, we need to talk about garbage collection. According to an executive summary from DMP, if you're running long-lived enterprise apps with 8 GB of heap or more, the Z garbage collector, or ZGC, is a monumental leap over the old garbage-first collector. ZGC was specifically built to handle massive heaps without those brutal stop-the-world pause times.
Here's the truly wild part. By doing all the heavy lifting concurrently with your application's threads, ZGC guarantees predictable pause times of under 10 milliseconds. And that guarantee holds up regardless of whether your heap is 8 GB or 4 TB. That means zero interruption to your users and incredibly consistent response times.
But to actually unlock this level of performance, you have to follow a definitive best practice. Set your initial heap size, XMX, to be exactly equal to your maximum heap size, XMX. Why? Because claiming all the memory you might need upfront completely eliminates the expensive overhead of resizing the heap at the operating system level during peak loads.
When you do make the switch to ZGC, you really have to be careful about what legacy flags you leave behind. It's critical to strip out obsolete generational flags and specific G1 GC parameters like max GC pause millis or G1 heap region size. Actually, scratch that. Don't just be careful, actively remove them. If you leave them in, you'll artificially handicap ZGC. Let it dynamically manage the heap regions itself for the best performance. And a quick tip on configuration, unless you are in a highly constrained containerized environment, keep your tuning super simple. If your Java app is the primary tenant on a dedicated server, you really don't need advanced uncommit flags like soft max heap size or Z uncommit. Trusting the collector's default behavior gives you maximum stability and saves unnecessary CPU cycles. Which brings us to our final part, Section 4, staying current with Java podcasts. To keep this modern developer mindset sharp, you've got to plug into the Community Hub. For deep dives into the JVMs straight from Oracle, Inside Java is a must. You've also got Fuj.io for great community insights. And for hands-on real-world troubleshooting and practical coding tips, Java Pubhouse is an absolutely essential listen for your commute. On the flip side, if you're focusing on cloud-native development or Spring Framework in production, A Beautiful Podcast and airhacks.fm provide amazing strategic architectural context. Plus, rounding out the list, you definitely want to check out Spring Office Hours and the Stacked podcast to learn how to scale out microservices and adopt modern serverless patterns. So, with instant startups, sub-millisecond GC pauses, and zero boilerplate, the excuses of the past are entirely gone. You have the ultimate toolkit right in front of you. If Java is no longer the bottleneck slowing down your deployments or hogging your cloud resources, what are you going to build next? It's time to rethink what's possible. Thanks for joining me on this explainer, and happy coding.